Hey everybody, how you doing? Here we go. We're going to learn something new today. Hopefully you've watched your videos from Mario, and we're going to talk about special right triangles today. And special right triangles can seem very, very confusing, and that's why I wanted you to watch the videos first. There's multiple ways of doing them, but I'm going to show you one technique. I'm going to show you this technique because it's on your reference sheet that you get to use for the EOC. So basically, we have two sets of special right triangles. One is a 30, 60, 90-degree triangle. 30 plus 60 equals 90, so we know that this adds up to 180. And the other one we're going to talk about is a 45, 45, 90 triangle. Now, a 45-45 should poke out or really pop out at you, because if the angles are the same, then the legs must be the same, and it must be an isosceles triangle, because if the legs are the same, the base angles are the same. If the base angles are the same, then the legs are the same. On a 30, 60, 90, we have three different angles. And if you notice that 30 degrees is half of 60, or 60 is twice as 30, these kind of go together with setting up the ratios of the sides. Okay, on a 30, 60, 90, opposite of 30 degrees is your smallest side. Opposite of 60 is your medium side, or I like to call it the longer leg. And then opposite of the right angle is your hypotenuse, which is your largest. So I'm going to call this small, medium, hypotenuse, or small, longer leg, because it's longer than the small leg, and hypotenuse. And on a 45, 45, 90, well, these two legs are exactly the same, because we said it's an isosceles triangle. And then we have the hypotenuse. So they're special. This one's special. Number one is special because one angle is twice as big as the other. And this one is special because the angles are exactly the same. And what that does is sets up a special relationship between the angles and the legs. We like to call this special relationship a 1, square root of 3, and 2 relationship, where 30 degrees is opposite the smallest, which is a relationship of 1. 60 degrees is opposite square root of 3, and square root of 3 is really 1 square roots of 3, and the square root of 3 is a little bit bigger than 1, and the hypotenuse, which is the longest side of a triangle, is twice as big as the small. And on a 45, 45, 90, that sets up a special relationship where if this is a 1-to-1 ratio, then if you think about Pythagorean's theorem, 1 squared plus 1 squared is 2 squared. When you take the square root to get c, we find the hypotenuse is going to be 2. Let me say that again. 1 squared plus 1 squared is the hypotenuse squared. 1 squared is 1. 1 squared is 1 equals the hypotenuse squared. 2 equals the hypotenuse squared. So the hypotenuse is simply the square root of 2. These are the special ratios of these triangles. And what we can say is, if we have any other triangle and we're trying to find a missing part, as long as we know the angles are 30, it's a right triangle, and then by default this one must be 60, there's a special relationship between these two triangles. They have to be similar because of angle-angle similarity. Since two of the angles are similar, then all three angles are similar. Or since two angles are congruent, then all three angles are congruent. Therefore, the two triangles are similar. If this side, which is opposite of 30, is 1, and this side is 2, then there must have been a special multiple of 2. 1 times 2 is 2. Then everything would be proportional by 2. 2 times 2 would tell me that this is 4. And 2 times 1 square roots of 3 would be 2 square roots of 3. And we're able to use these relationships to find similar triangles. Same thing holds true with a 45, 45, 90. Ooh, that's a really ugly 45, 45, 90. Bah, just don't worry about how ugly it is. Let's just use it. If this is 3, then this one has to be 3 because it's isosceles. And if this is 1 and this is 3, then 1 times 3 gives me these two are 3. And if this has a relationship of square root of 2, then this is 3 square roots of 2. And these similar triangles are very proportional. And I'm using scale factor to kind of simply show you very quickly that we know that scale factor is nothing but a multiple. And if the numbers are simple, then it's a lot easier to find the new ones. Okay. They're not always going to be that easy, but I wanted to kind of show you that they are nothing but similar triangles, and we don't have to freak out just because they look ugly and they have square roots in them. All right, now I'm going to give you one or two problems and show you the application of how to set up ratios and proportions to solve them. Every time you get a 30, 60, 90 or a 45, 45, 90, I want you to draw the triangles. So here we go. On your paper, I want you to draw, and it doesn't really matter which area the 30 or the 60 goes. You just have to remember that across from the small angle is the smallest side, and we're going to call that a ratio of 1. Opposite 60 degrees is the medium or longer side, and we said that was really 1 square roots of 3. And the hypotenuse is the largest, and just think it's twice as big as the small. Now, let's say we have another triangle that gives us an empty measure. Let's say we know that this is 10. And we want to find x. We have to set up a ratio and proportion using the original proportions to create new proportions that are corresponding. Remember, we have to write connecting parts or corresponding parts equal to each other. Now be careful. On this triangle, I intentionally drew the 30 degrees up here. On this triangle, I drew the 30 degrees down here. That forces this to be my small side. That forces this to be my small side. So when we go to put these together and they're corresponding, we have to be very, very careful that we set up our triangles or our proportions correctly. Remember, ratios and proportions set four things equal to each other. A over B equals C over D. We always need to have four numbers. We did this when we did similar right triangles, when we did the triangles inside of each other. Okay, let's see what corresponds. According to this picture, they want X. And this is my medium or my longer leg. So we're going to have to compare this one to the medium or longer leg, which is here. Now, when we go to set up our ratio, you need to decide, am I going from the top triangle and comparing it to the bottom? Or are we going to compare the bottom to the top? Because of the way I drew it, I'm going to compare top compared to bottom. Okay? And because X is my medium or long leg, I'm going to compare it to the medium or long leg up here. So 1 square roots of 3 compared to X is going to be equal to, and the other two that we have available to us is the hypotenuse. So since I started with top over bottom, my other side is going to be top over bottom, and I'm going to compare 2 to 10. And then we simply cross multiply. X times 2 is 2x, and 10 times 1 is 10, and times the square root of 3. How do I get x alone? I divide each side by 2. X equals 5 square roots of 3. And there we have it. X is nothing but 5 square roots of 3. Now, if you know that these triangles are nothing but scale factor or multiples, and we know that this is 2, you can't see what I'm pointing at. If we know this is 2 and it goes to 10, we knew that that was a multiple of 5, right? So all parts have to be multiples of 5. So the small side was 1. If we multiply 5 times 1, then the short side has to be 5. If we take the medium side, which is 1 square roots of 3, and we multiply it by 5, we end up with 5 square roots of 3. So these are not hard. It's dealing with the radicals that makes it a little bit tricky. When you start on your IXL, you're going to be confused at first. But once you get the knack of it, once you understand how to get there, it'll go really quickly. Let's do one more before I go on to a 45-45. Okay? Every time I want you to do your original triangle. Again, it doesn't matter where you put the 30 or 60. What you need to identify is, this is my small side, which is 1. This is my medium side, which is the square root of 3. And my hypotenuse always has a ratio of 2. Then you set up anything that they're giving you and make sure that you line up small side, medium side, or longer leg, and understand where your hypotenuse goes. All right, and it doesn't make any difference at all to me what kind of number you come up with. We should be able to figure out the small, medium, and hypotenuse. All right, let's say the medium is 10. Find the small and the hypotenuse. Okay, so the first thing you're going to do is we're going to say, hey, I'm going to start with top compared to bottom. We know we're going to have 4 parts that are equal to each other. And we start with what we know. In this particular case, we know the square root of 3, which is opposite of the 60. And we know 10, which is opposite of the 60. So those are going to be corresponding, so therefore we can compare them. Again, top over bottom. So we're going to take square root of 3 or 1 square root of 3. It depends on how you want to read it. You don't have to put the 1 in front, but I'll put it there just so you see that it is a little bit bigger than the small. Compared to 10 is going to equal, now let's compare hypotenuse compared to hypotenuse. Again, we're doing top over bottom. So we're going to take 2 and compare it to the hypotenuse. Cross multiply and solve. 10 times 2 is 20. H times 1 square root of 3 is nothing but h square roots of 3. How do we solve for the hypotenuse? Now this is the tricky part, and this is why those simplifying radicals came in handy. We're going to divide each side by the square root of 3. Square root of 3 divided by the square root of 3 is 1. 1 times h is h. And 20 divided by the square root of 3. Now, that's an answer, but it's not in simple radical form. And we don't want to leave the radical in the bottom. So in order to get rid of the radical in the bottom, we multiply by a special number 1. And that special number 1 is simply square root of 3 over the square root of 3. Square root of 3 divided by the square root of 3 is 1. And then we multiply across. 20 times square root of 3 is 20 square roots of 3. And square root of 3 times the square root of 3, for every 2 that's under the radical, you take out 1. And the hypotenuse is 20 square roots of 3. Now we could set up a second proportion to find the small, which I'm going to do, but I want you to see there's an easier way to do it in just a minute. But let's go ahead and set up a second proportion. Okay, you always have to start with something you know, and we started last time with square root of 3 over 10. So we're going to start that way again. Square root of 3 over 10 is equal to, now we're going to compare the small compared to the small, because they are corresponding. Small compared to small. And the ratio is 1 to small. Cross multiply and solve. We end up with small times the square root of 3 is small square roots of 3. And 10 times 1 is 10. How do we get the small by itself? Divide by the square root of 3. Divide by the square root of 3. I don't really want that. 3, square root of 3 divided by square root of 3 is 1. 1 times s is s, and we end up with 10 square roots of 3. Hey, we don't want the radical in the bottom, so how do we get rid of it? By multiplying by a special number 1, which is the square root of 3 times itself. The small side equals 10 times the square root of 3 is 10 square roots of 3. And square root of 3 times the square root of 3, for every 2, you take out 1. And there you go. That's using what we've learned before. Proportional triangles should be proportionate. Now, remember that the hypotenuse is twice as big as the small leg. Once you remember these rules, it would be easy to say, hey, if the hypotenuse is 20 and it's twice as big as the small, could we divide 20 by 2 and simply get 10 square roots of 3 over 3 and come up with the same answer? Yes. That is the beauty of special right triangles, and that's why they call them special. Because they're proportional, we could use the proportions that every 30, 60, 90 has. 1, 1, square root of 3, 2. Now we're going to do the same thing with 45, 45. Hold on a second. I think I still have a little bit of time left. I just want to make sure that I don't go over my time. 45, 45, 90 are even easier. Why are they easier? Because there's only one special relationship. Is that if this is a leg, that's a 1. If this is a leg, it's a 1. 1 and 1 is 2. Take the square root of it. It's a 1, 1 square root of 2 relationship. Hey, let's say the hypotenuse is 10. We set up proportions and solve. What is the length of this leg? Easy peasy, lemon squeezy. Top compared to bottom. And we will have 4 pieces to fill in. Always start with what you know. Square root of 2 corresponds to 10. 1 is going to correspond to L. This is really a relationship of 1, 1, square root of 2. Here we go. Square root of 2 compares to 10 as 1 compares to L. Square root of 2 times L equals 10 to 1 is 10. Divide each side by the square root of 2. Hey, we don't want 2 on the denominator, so we multiply by a special number 1. The leg equals 10 times the square root of 2 is 10 square roots of 2. Square root of 2 times the square root of 2. For every 2, we take out 1. Now we're almost finished. This one happens to be reducible. 10 divided by 2 is 5. And what is left is the square root of 2. And there you go. All right. Those videos I gave you Friday to watch over the weekend. If you haven't watched them, watch them again. This section isn't hard. Once you know one leg, you know the other leg. It's a little complicated because you've never done it before, but trust me, once you do a few, you'll start learning some shortcuts really quickly. All right, guys, have a good day. Try your IXLs. Make it happen. Bye.